Students, in this video we're going to look at an example of crashing, which is from exercise 15E. And the idea of crashing is that we're taking an activity network but reducing the times of particular activities in order to try to complete the project faster. And sometimes in these questions as well you have to consider how much it might cost to reduce these activities. And so usually what you're trying to do is make the reductions as effective as possible but not waste any effort or time in doing it. Okay, so let's have a look at how this works. So we're actually using the same example from the previous video on 15D. So we've got this activity network with 13 activities, but this time the question says activities K, L, and M can all be reduced by 2 days each. What is the minimum completion time of the project and which reductions should be applied? So typically with crashing questions, the best place to start is to actually list out all the possible paths from start to finish, because the key thing that you actually have to find first is which one's the critical path. So we did this in the last video, but let's go through it again. If we kind of go through the possible paths from start to finish, if we go sort of across the top first, we've got path A, D, K, and when we add up the times of A, D, and K, that gives us 14 days. And the next possible path would be A, E, I, K, and that when we add up the times adds to 15 days, 4 plus 4 plus 2 plus 5. Then we've got the path through the middle, B, F, L, and 3 plus 7 plus 4 gives us a time of 14 days. Then we can go down to the bottom and C, G, J, M gives us a total time of 14 days, 1 plus 4 plus 6 plus 3. And last but not least, C, H, M, that path has a total time of 13 days. Okay, so I guess what we've done here is listed out all the possible paths from start to finish. And the key here is that, or probably the first thing we have to look at least, is that this path A, E, I, K is the critical path. So basically what we want to do is make sure that we can reduce the critical path first, because if you can't reduce the critical path, then there's basically no point reducing anything else. Because if we're trying to get the overall project to finish as quickly as possible, if the critical path is stuck, then you can't reduce the overall project's completion time. Okay, now let's look at what we actually do when we start to make some of these reductions. So let's look carefully at the options that we've got. We've got activities K, L, and M that can be reduced by 2 days each. Now, just to show you where they are, we've got activity K here, activity L here, and activity M here. So these are the ones that can be reduced. Of those 3 activities, the one that's on the critical path is activity K. So that's definitely going to be the one that we want to reduce first, okay? Because we need to get that critical path down. So let's have a look. I'll use a different color here so it's not confused with the red. So let's reduce activity K. Now there's different ways that you can kind of keep track of this, but what I tend to do is just like put a line or something like that over it. Not so heavily that you kind of can't see what the letter was. But you also put it, if K is on any other path, like this first one, you can put a line through it there, because obviously that's going to reduce both of those paths that have K on it. And if we apply the reduction by 2 days, then what's going to happen is that this first path that was 14 days, well, that's going to come down to 12. And the second path, the critical path that was 15 days, that now comes down to 13. All right, so that's good. We've made a reduction that's actually reduced the critical path. What you'll notice now is we've actually created a new critical path. So we've got these other 2 paths here, B, F, L, and C, G, J, M. They're now the 2 new critical paths because they're the longest ones. So what we should try to do is, if we've got more things we're allowed to reduce, we should apply those reductions to see if we can get both of these paths down. Now we have to try to get both of them down, right? Otherwise there's no point, but let's see if we can get both of them down to 13 or less. Okay, so we have options for reducing activity L, right? So we can reduce activity L, and we also have the option of reducing activity M. That's fantastic. And we can reduce both of them by up to 2 days if we want to, right? It says they can be reduced by up to 2 days each. Now, if we reduce them by 2 days, both of those paths will come down to 12, which is fine. That'll be a reduction. But notice that we still have these other 2 paths that are stuck on 13 days, and we don't have any activities that we can reduce to get them lower than 13 days. So 13 days is actually already the minimum time that we can get down to. So there's really no point reducing activity L or activity M by 2 days. It's kind of likely to be a waste. If that's costing money, we're reducing it by too much. Really, all we need to do is reduce it by just 1 day to get both of those paths down to 13. And so that's what we're going to do. We're going to reduce activity L, but just by 1 day. I'm just going to put the number 1 there. And reduce activity M as well, but just by 1 day. And so this 14 comes down to 13. This path that was 14 comes down to 13 as well. And now we've got, I guess we've gone as far as we can go, right? Because we still had these other paths that were stuck on 13 days anyway. Like we said before, it wouldn't have made sense to reduce those ones down to 12, or it wouldn't have helped to reduce them down to 12 because we would still have these 2 other paths that are stuck on 13. So we've now made, I guess what we've done is we've made the fewest reductions possible in order to get down to the minimum completion time. Okay, and that's what the question was asking us for. So when we go to answer the question now, we can say, well, what is the minimum completion time of the project? The minimum overall completion time is 13 days. And which reductions should be applied? So what we did was we reduced activity K by 2 days. Okay, that was that first reduction that we made. We kind of did the full reduction on K. And then we reduced L and M, but only by 1 day. Reduce L and M by 1 day each. So those are the reductions that gave us our new minimum completion time.